Hello everyone and welcome to today's webinar, Test Design Essentials for Great Test Automation with Hans Buwalda and Titus Fortner. Before we get started, I'd like to go over a few items so you know how to participate in the event today. When you join today's webinar, you selected to join either by phone call or computer audio. If for any reason you would like to change your selection, you can do so by accessing your audio pane in your control panel. You will have the opportunity to submit text questions to today's presenters by typing your questions into the questions panel of the control panel. You can go ahead and send in your questions at any time. We will collect these and address them during the Q&A session at the end of today's presentation. I'd now like to turn today's presentation over to Hans Buwalda, CTO for LogiGear.
Hi everybody, this is Hans. Nice to meet you. We're going to talk about test design a little bit. Not as much test design for like great quality test, even though that has to do with it. I'm going to focus very much on the role that test design can play for good test automation. And after me, Titus will come on. Titus will make it more concrete. My part of the story is a bit academic, a bit esoteric, but with Titus it will become more concrete, particularly in Selenium. So let's make a start. Here I try to draw a picture of what I see as a typical Scrum project. Not necessarily a perfect Scrum project, but I've seen many of these where we have the product owners, the developers and the QA nicely work together, and that cooperation often goes quite well. However, the sprints move on, it goes very fast, and particularly if the QA wants all the functional tests automated, there is a risk of running behind. And once you start running behind, that means you're in a different sprint than your developers and your product owners, and that makes the coordination more difficult. And that means you even will fall further behind. And then you typically see the pattern that the team is in sprint 25, but QA is still automating the test for sprint 23. So this talk, we'll talk about what can we do about that. I'm working with test automation for a long time already. When I came into the industry, test automation was kind of a nice to have. And when you were talking with a manager or a customer, there would always be that question, what should I automate, what should I not automate? And the discussion was usually based on an ROI, a return on investment. How much does it cost me, and how much does it benefit me? And based on that, should I automate or should I not automate? So in most projects, a typical automation rate will be maybe 30% or so, 40%, but definitely not everything. What I noticed when Agile came along, you got things like test-driven development and acceptance test-driven development, and most of all also BDD, and behavior-driven development. You see that automation becomes more a must-have to make the sprints go well and to remain your agility, meaning you can quickly make changes to a system. You don't have to worry about having to test everything manually again. Automation is much more a must-have. I don't hear these discussions anymore. Should I automate or should I not automate? Ideally, that focus is shifting now to, should I test? Is this something I need to test? Is that something I probably not need to test? How thorough need the test to be? And what should I involve? Now, lately, we're all in the DevOps mode, meaning projects are now more a combination of development and operations, meaning that the build process and the deployment process also gets automated. Now, not only make that test automation become a must-have, it also needs to be very stable. And we see really customers and big customers come up with, it needs to be 100% stable. The problem is if a test breaks, the pipeline breaks. So any problems that come out of an automated test run should be due to the application under test, real bugs in the application under test. And it should not come from the test. So we double our efforts as an automation industry to make that happen. And again, I recommend listening to Titus's part. He will talk a lot about that. I like this picture that is called the test pyramid. And it was in a book from Mike Cohn and has become very popular since. And what it kind of depicts is what level of tests would you like to have and what level of automation. And as much as possible, what you want to do is to do it at the unit test level. And that is close to the developers or done by the developers. And you basically make a test for each function in each class that you produce. Is highly maintainable, so it's a good idea. Whatever you can do at that level, that's great. Then the next level up is simplified, is the service or component level, where the units come together to form a subsystem, and that can either be a component in an SGTI or it can be a service like a microservice. And the tests you focus on that level also tend to be very stable and can very fast, so that's also a good idea. Left over is the test you do for the UI. Now, I kind of disagree a little bit with the original picture, so I put my own version next to it. I do believe tests running through the UI can be very useful. You should definitely consider that, because in the UI is where it all comes together, all the parts of your system under test. And that's where you're going to see the bugs most likely. And you should also not avoid UI because it's hard. And that President Kennedy said we go to the moon not because it's easy, but because it's hard. And what we hope we can show in this presentation, that testing for the UI also doesn't have to be so hard. And another simplification here, but here you see, before I go there, let me go back. There is a poll question. We would really like to know what you guys do right now. Is most of your tests at the unit level? Is it at the component level, sometimes also called the API level, or is it through the UI? And that is for the tests, and also interesting to know for the automation. So I give you a moment to do this, and then we move on to the rest of the presentation. But we're very interested in hearing you about this. Okay, I don't see the poll results just yet. They are being shared with me.
So we do have the polling results on screen. It may be on the control panel of the GoToWebinar platform, but I'll just read them aloud to you. We had 41% say our tests are mainly through the UI. 60% said we use both UI and API services testing, and 8% said our tests are mainly through the API services layer.
Wow, that's interesting. That shows that especially that middle layer is the most interesting challenge right now. So, and I think that's quite relevant because we're going into an age where there is a lot more service-oriented architectures running in what is called containers. It's kind of a small virtual machine architecture. And those services get very focused. That's called microservices. So your system will typically consist of many microservices. And what's the currently interesting question is, how do you automate? How do you test? Do you only focus your test on a single microservice, or do you test a lot of those microservices together in kind of an integration testing approach? And do I have all the answers? Probably not. I do write a lot about these topics. I have my own webpage called Happy Tester, and because testers need to be happy, happytester.com. That's where you can find my articles, and I will keep writing about these topics as well. And your feedback is more than welcome. Hans@logigear.com. I really like to hear from you. So let's move on a little bit. So this is a slide that kind of typifies the kind of test that you can do. And we have the unit testing, that's kind of at the lowest level, that is automated by nature. And that is also relatively scalable and easy to maintain. If you have 10 more classes with functions, you will have a bunch more unit tests. They do tend to be very effective in the beginning. Eventually, they don't show much anymore because, yeah, of course, the functions will pass. If you don't update those functions, not much will change. On the other end of the spectrum is exploratory testing. That is, if you're not doing that already, I would definitely recommend you to take a look at that, more oriented on functionality, where testing is seen as a learning process. I won't talk about it too much today, but I definitely recommend. What I will talk about today is the functional testing. That's a very broad area, from acceptance testing up to integration testing and system testing. So everything that goes beyond the unit, and that kind of testing where the system under test becomes more like a black box that you have to address. Now, if that goes through the UI, I'm sure you are aware that that can be pretty hard. It can be a challenge, and so it becomes often a bottleneck in the scalability of your automation. So let's talk about automation. And the message of this slide is that good automation is not just about automating manual testing. And we go back 120 years. People were riding around in carriages. There were no cars yet. And what happened about 120 years ago? The horses were gone, and instead we have an engine and a steering wheel, but the design of the carriage is still the same. I have some examples here. These are early cars, but they still look like carriages. If you look at the car on the top left, that's actually a Porsche. Was created by Mr. Porsche himself. Was an electrical car, and you can see it still looks like a carriage. Now, if you look at the current times, and this was my previous car, that was the car that I had when I made this slide, it doesn't look like a carriage anymore. There is no room to put the horses, nobody sitting on top of the car to guide the car, even though in the current Bay Area traffic that might not be such a bad idea. And the message here is that good automated testing is not the same as automating good manual testing. And by having an engine means the entire design of the car has to be adapted to accommodate that engine. So automation is also kind of an engine. The fact that you're going to have this automation means your entire process from test design to automation needs to be re-engineered to make that automation successful. So let's see how we will do that. And so the statement is, successful automation is not as much a technical challenge as it is a test design challenge. Occasionally, it is a technical challenge. If you have like a third-party control on your screen that your test tool doesn't understand, or you have a flash control in a web page, sometimes it can become very technical. But that ideally, that's only for a short amount of time. You fix that technical problem, and then once that is fixed, you can go back to your test design and focus on the test design. Now, what I will show you is that the test design is not only important for the quality, but it also helps your automation. And so the two reasons to have test design, first of all, quality will be better. Second, automation will be easier. And that's what we will talk about today. And to show that, I have an example here. This comes from a real project. I didn't make this up. What I did do is change the name of the company and change the name of the products, just to make sure you don't recognize which company this is. But I've seen this happening. And when you look at this test, it doesn't seem to make much sense. It's a good test. It's even a test that is easy to automate. And we're just clicking buttons and look at the dialogues. It's not particularly difficult to automate. Still, it's hard to say from the test, what are we actually doing here? And you can imagine if you have, let's say, 50,000 lines like this, that it becomes very hard to automate. And that is not a technical problem. That's not because the test tool wouldn't be able to do it. The problem is that the test design is not really ready for automation. The test design is so convoluted with all kinds of low-level details intermixed with more business-oriented tests like what is the price of the watch. And that means that the automation becomes very difficult. So is it a good test? Maybe. Is it suitable for maintainable automation? I don't think so. And this particular project, sorry, we definitely had a problem there. So that means that the design of the test is very important for the automation. However, the average tester is not necessarily an engineer. So how to do that? Especially when the testers are not technical, like domain experts, business analysts, people like that. They might, many of you might be like that. They either have no programming experience, or even they do, but they don't really care for it much. So what you do is you kind of pre-structure your test. I like to compare that with a closet with shelves, or, for example, a table of contents of a book. So what you do together with the developers and the automation engineers and the product owners and the testers, together you define a pre-structure. I call it pre-structure because in most cases you're in a Scrum project or something like that. And that means that the actual test will only come much later. That will only come when the sprint actually hits that particular functionality. But you're already labeling the shelves. So you already make a distinction between test scripts that are going to do the high-level business logic and test scripts that are going to do more the interaction. I'll show you an example later. And then so you do that early in the project. In my experience, that is maybe a few hours or a few days of work. Once you have that, you can go into your regular sprint schedule again, and you can, when you then hit that particular test, now you're really going to define the test. Because it's pre-structured, now you don't have to be a technician anymore and an experienced engineer and to do the refactoring to make the test maintainable. Here are some of the dimensions that you can use to break your test down, like the functionality of the test, the architecture of your system under test, what kind of test, is it navigation flow, is it a negative test, is it a response time, or many others. And then if that does not give you enough granularity to define those scripts, then go for some other criteria like complex tests, put those in separate test scripts. But any risk areas, you might make some extra tests for those, etc. And what you do when you develop the test, you always keep an eye on the ball. So know for this particular test, that is my scope. And Titus later on will make this more concrete when you do this in Selenium. And you have a certain scope. That scope should be clear. It's either this or it's that. And then that determines the rest of the test. What kind of test cases? Are they very detailed, or are they more broad and global? What level of detail do you need to specify? What do you need to check? What do you need not to check? So let's see how you could do that. This slide and the next slide is a differentiation that we are using in our projects and that we have experienced as one that works and gets you to that pre-structure quickly. The first step that you do is what kind of business objects do I have? That's not necessarily the objects as in object orientation, but it is closely related. It is like if I have a car rental company, there is the cars, there is the invoices, the orders, the locations, the staff members, etc. When you do that, probably about 80% of your test fit in one of those categories, one of those business objects. And for the business object, you typically follow the life cycle. We'll see that on the next slide. Then the next big category is the business flow, in which you have your end-to-end processes going through all these business objects together. A customer comes in, which is a business object. He or she orders a car. The order is a business object, the car is a business object, the location, the parking lot, the agent helping the customer. So that is a flow that goes through all of those business objects. And then what's left is a lot of other categories of test, like administration, security, and graphics. Graphics are usually good to do that in separate tests because it's fairly complicated. Anything that needs a high level of technology, and let's say you have embedded software, you need to actually go into the device with some ports or some connectors and do that in a separate test so that it does not hit anything else. And in sauce labs, you can choose between physical devices and logical devices, virtual devices. So that would be a determination that you can make here. Interoperability with other parts of your system or with other systems or services, etc. Once you have done that, let's say you now have a business object, then you need to distinguish between what are more the business tests, like the life cycle of a business object, and what's more like the UI details. And in the business test, you should not have things like click a button or select a menu item. That is too detailed for a business test. While in an interaction test, that's exactly what you would do and what you would make visible in the script. So in a business test, you might say, is the monthly premium $732.22? While in the interaction test, you want to know, is the OK button enabled? These are very valuable tests, but they should go in different scripts. Otherwise, if you mix that in, you become too sensitive to maintenance. So it could look something like that, as from a top-level structure. And you start with business objects. I gave an example, cars. And then within the cars, you go through all the dialogues for your interaction test, and you go through the life cycle for your business test. Can I create a new car, enter a new car? Can I update the car description? Can I close the car, delete the car, etc. So let me give you an example, and then I will hand it over to Titus to make it more tangible and concrete. Let's say I have an e-commerce site, like Amazon, but it could also be Coach for bags or something like that. Typically, these are some of the business objects that you will see. Articles, categories of articles, customers, etc., etc. Let me focus on one category, promotions. So that's the business object I'm going to talk about. Now first I analyze what kind of promotions I have. Percentage based or fixed dollar amounts. Is it worldwide or is it regional or state? Is it based on the volume? If you buy 3, you get 1 for free. Is it prompt payment in business to business? If you pay within 30 days, I give you 1% discount. Is it a specific article or article group, or is it comprehensive? And then you can look at life cycles. So now I create a promotion. I modify the promotion, where it's very interesting whether you do that before you activate the promotion or after it's already activated. The promotion needs to expire elegantly, and you need to be able to cancel a promotion if there is a problem. And then when I look at the interaction test, I see, can I get from screen to screen? For each screen, I will do a bunch of tests. If I have a discount field, can I switch from percentage to fixed? Does that change the amount in that field? Stuff like that. If it is a regional box, list box, drop-down box, or checkbox, does the region list show up? Can the region, are the regions correct? Can the regions be selected, deselected? And low-level test. And for example, I have start, duration, and end date. If I change the duration, does the end date change? That kind of things. So here is an example what kind of test you could see. A business test will talk about the business. It will not talk about buttons and trees and tables and whatever have you. So I create a promotion. It goes from December 1st to December 25. So a Christmas promotion, 11 discount on all inventory. I'm in a generous mood. And then I have an extra promotion. This runs from the 20th to 23rd of December. 20% discount on only the tablets, only the tablets. Now, I do a little time travel. I set the date to 12/23. Automation engineer is to figure out how to actually do that. I don't worry about it. I'm a tester. I just do. And then I check the discounted price on an iPad Mini 4, and then I expect a certain value. So purely business. I could even do this test by hand, manually. You wouldn't know. The same test would work on a desktop, on a web page, on a mobile device. It would be the same test, no problem. And then the interaction. Now I'm detailed. I click on a button on a screen. So this is typically UI oriented. This would not work for a microservice. I select state specific, and now I check all the US states. So I will start with US Virgin Islands, Puerto Rico, Washington DC. Of course, being a mean tester, I would pick the ones that might not be in the list. Okay, maybe it's a good time to do another poll now to talk about what kind of frameworks and tools you're actually using right now. And then I would like to give it to Titus and to show us how to actually do this. So here is the poll question. And we're interested in what kind of framework, because the framework highly influences how much of your details you can hide behind the script, behind an action, behind a subroutine, behind the BDD scenario, whatever have you. So choosing a framework can be very important. And you can also just do that in simple scripting. I think Titus has a very elegant example in Selenium coming up, where he really scripts it with subroutines. So you don't always need a framework. Let's see what we have. Okay, quite a few open source. That's great. Some proprietary ones. And no framework at all. All three of those are correct answers. None of this is wrong. It is just a matter of what fits into your situation. Okay, that concludes my slides. So I would gladly give it to Titus now. And then take it away, and thanks for your attention so far.
Thanks, Hans. This is Titus from Sauce Labs.
We have tested this. Now we
Can you see my screen? I'm not sure.
We still see you in design mode.
Oh.
And for everybody who's watching, we have tested this.
Okay. There we go. I'm used to seeing it say that you can see. So you can see this now, Hans?
Yes, we can.
Great. All right. Thank you. So I really want to echo a lot of the big points that Hans was making there, because I like to phrase this as think before you test, because when you look at the total costs of doing automation, the amount of time and energy and money it takes to create a test suite it pales in comparison to the amount of time and energy it takes to maintain it, especially if what you created is not structured well. And so thinking ahead of time about what you're testing and why and how it's designed and what framework you're using, like putting extra time and energy into that up front is definitely going to provide a lot of dividends down the road. And so like I like to think on each test, like what does a failure indicate about whether or not the system is operating correctly? And if it passes, is that telling me useful information? And this comes back to kind of what Hans was saying about not just automating all of your manual tests. I can't tell you how often I see when I'm working with clients, their manual test cases are part of the list of, are included in the automation that they've done. So it's essentially, it's a one-to-one transfer of this is what I did manually and this is what I'm doing and here it is automated. And we'll see some reasons why that that's not as successful as it could be. Again, trying to show what can a car look like if you're not stuck to the model of just making it look like what the horse-drawn carriage looked like. So another aspect of this is framework design. So this kind of goes hand in hand with test design as far as the approach of thinking ahead of time about how to structure things so that you're getting the most value for the least pain and effort. And here are just 6 different ways, 6 different components to a good framework. And this is something to keep in mind as far as how you are, like a good framework is going to provide a place for everything and have an obvious place for you to go to if something needs to change. So the idea is that you don't repeat things in many places and you know exactly where to go when you need to maintain, when something changes and you need to maintain it. And if you've got the same information in a lot of places, or if one change to a site in one place requires you to change a bunch of things in your framework, then you're not doing, your framework is not helping you as much as it could. So having your configurations and settings in one place, having the one place for your initial setup and teardown, obviously your assertions on your actions, which are your tests. Page object is the site modeling abstraction that I prefer. And then the wrappers and helpers, there's a lot of powerful things you can do by putting common code around specific actions that you take frequently, like clicks and sending text and things like that. And then also data is a big thing that I could probably talk an entire hour on just on its own. But let's take a look at kind of an example here from a manual test point. I've got, this is a Rails app that I created just to kind of show this off, and this is how I would go about approaching this as a manual tester of like, okay, I'm gonna sign up and then sign out so I can log back in with what I just signed up on. And the idea here is to kind of go from the beginning to the end of this flow in the most efficient way possible. Like that's how you need to do it as a manual tester, is be really efficient with how quickly you can cover all of the things. And maybe as part of this, you would be testing to make sure that the sign in link isn't still there, or you would test if you put in a malformed zip code, does it give an error? This is just kind of showing the happy path of interacting with, creating and reading and editing and deleting a test, or an address in this case. So yeah, so the first step then we're going to destroy, and it's not there and everything's good. So if we translate that into Selenium code, and I'm the maintainer of the Ruby bindings for Selenium, so all of the examples here are going to be in Ruby. But hopefully it's easy enough to read that you can at least see kind of what's going on here if you're familiar with how Selenium works. But this is what all of that would look like doing just directly in Selenium code. And you can see there's a lot of repetition and a lot of stuff that's not obvious what's going on here. But let's take a look at what actions are actually being taken. We'll just break it up into these are the kind of what I did step by step to do these things. But when you think about it, again, from kind of a design standpoint, are all of these actions that I took equally important? No, like the big things that we care about are, can you sign up? Can you sign out? Can you sign in? Can you create? Can you edit? Can you delete? And all of these other things are just kind of glue, essentially, between verifying these things. And yes, navigation can be important, but again, it's not as important as this functionality. And so keeping in mind what your focus is can help you make additional choices for how you can structure your tests and your framework. So the first thing here that we're going to talk about is splitting these up. So essentially, as a manual tester, you're going to do everything as a flow, with a beginning to an end, to go through this whole process, because that's the efficient way to do it. Well, when you can automate it, this allows you to do the same kind of thing, but splitting it up into individual chunks that represent each of the things that you actually care about. And if you notice, there is duplication in all of this. Like you'll see that we're doing the sign up, visit, submit form with the user data in every single one of these tasks, because you need a user in order to do these things. But you don't have to, for instance, edit something before you delete it. And so you'll notice the delete method, which was the last thing we did when we did it all in one go, is much shorter than it would be otherwise. So I'm going to show you what this looks like running on Sauce Labs. So essentially, I'm kicking off running what we saw the first time, the serial, the one big test. And then I'm also going to kick off running all of this in parallel. And so this will take a couple minutes to go, but essentially what we're seeing here is we've got the automated builds tab you can designate when you create a test suite an entire build run to have a specific name so you can keep track of it. You could also take a look at the automated tests list here. So this automated tests tab will show you all of the individual tests that are running. And so you see all of the parallel tests there, and then the one that was testing in serial is also running. So now if we go back to automated builds, we've got parallel. There's 8 tests getting run at the same time there. And here we can see them all running at the same time. Some have already done. So let's take a look at one that's finished here and take a look at it. So you see there's a list of each and every Selenium command that was sent to Sauce Labs, which then passes it on to the driver to interact with the browser. And we'll even be able to show you a video. So there were screenshots around those commands that you could see, but here if you actually want to see the playback of what actually happened, you can see an exact playback. So let's go back and take a look at these results. Oh, let's also take a look at those. So Sauce Labs also provides the logs for all of the things, and probably more interesting is the metadata that we give. And so this is where like the name of the test or the build and things that you passed in as far as I want to test on Chrome or what operating system, things like that. And then you can see like the screenshots that we saved at the bottom there. All right, so now let's go back and see how our tests are doing. Our parallel tests are done. They took 1.5 minutes. The serial tests are still running. So let's take a look. Ah, something failed. What failed? We don't know because we ran everything all at the same time. So there's all of these different functions and something didn't work right. And in order to figure that out, we're now going to have to dial in and then go down and explore in the commands, like what command did we get back here? Oh, it's saying it can't find the first name. So it's going to see the first name if we're looking, it looks like we're looking to edit this. That's the next step, is to click edit on that so we can edit it. But for some reason, it didn't click that edit button, and so now it didn't click the edit button, and so it couldn't find the thing that it needed to find next. So let's go ahead and, so essentially the interesting thing about looking at a failing test like this, when you break it up, you know exactly what the problem is, and it's really quick and easy to go in and address it. And so when I reran this and fixed that issue in serial, you'll see that it took 2 minutes and 55 seconds. But then when I ran it in parallel, it only took about 1.5 minutes. And so just by cutting out some of the common repetitious things that get done, and if you have enough bandwidth to run these all at the same time, you can see drastic reductions in the amount of time it takes to get the overall results from your test suite. So another thing that I wanted to quickly talk about is just options for avoiding the browser overall. I've got some examples that, well, we might look at, but essentially the browser, and so especially if you are using, if you have a mobile app or if you're using something like Angular or React, your web application has an API of some kind that these different user interfacing applications can interact with your service layer. And essentially, you can maintain the black box ability to interact with your service by going through the API, and it doesn't matter if it's through a browser or if it's through a mobile app or if it's through some kind of HTML client, like some kind of net library or a REST client. And so if there are things that you can do to take actions in without opening a browser, you can also see things sped up quite a bit. And so, for instance, one of the big things that I see is being able to log in users with a cookie instead of using a form. Things like that can drastically speed up your execution. I'll show some code here just to kind of show you what I'm thinking. And it's essentially logging in a user is going to be visiting the home page. And then if we can just create a user without going through the form and then adding the cookie that has the information that authenticates that user for the site, essentially you're just grabbing a random data. You don't care what the username or the password is. You just want a user, and then you're going to pass that information in to, if you look at the call equals here, there's a user's endpoint that the API is reading information from. Like, post that payload to that endpoint, and what you get back is there's going to be a header, and you're going to grab the cookie out of the header, and then the token you want, that's just a regular expression parsing to grab that particular information. But the idea is now I have this cookie, and I add it, and now I didn't have to go through the UI in order to get that information. And you could do a similar thing. Here's also code for creating an address. But essentially the same idea is that you can create an address the exact same way you would through the browser, only doing it through an API. And when you do these things, you can see you can get this down to like 45 seconds because you're doing all of the setup and the verification without needing to go through the UI and without changing the fundamental nature of what you're testing, because it's still the exact same test. It's doing the exact same things. It's just not taking the slow route. But yeah, and so I think one of the things that I glossed over really quickly that I wanted to specify here is when we're showing this here, I wanted to reiterate some of the stuff that Hans was talking about as far as the business tests, and really, like, there's no specific clicking, there's no reference to a Selenium driver, there's no specific data because we don't even care what the user data is. We just want to create a user and then use that user's information. And so finding a way to abstract all of those details out into either a data class, which is what we're doing for this user and the address data, or abstracting it into a page object where, hey, what does the visit method do to get you to the sign-in page? What does it mean for the message to be created? Put that method on the page object rather than in the test itself. And so this is something that I like to start with the test that you're writing, and try and, like, these should be understandable. Like, even if you don't know code and you don't know Ruby, you should be able to show this to your manager and have them kind of understand what each of these tests is doing based on just the words that are being that are used in the naming system that you have. So that's all I have for this.
Sounds good, Titus. And it is, it makes it concrete, what I was talking about. So that's great.
Absolutely, and thanks, Titus and Hans. This is Bill from Sauce Labs, and I've got some questions that have been coming in throughout the presentation. Since we just talked about API tests, Titus, I've got one question here from Beth that I'll throw your way. I don't know, it may be something that can be addressed quickly. It may be something where you say, I'll give you a quick answer and we'll do a webinar around it all by itself. But she asks, where do you run the API tests? Right from the build server without Sauce Labs?
Yeah, so it depends, right? Yes, typically when you're looking to do a continuous integration setup, you have different I don't know, like I do a demo for continuous integration, continuous delivery, where on pull requests things are automatically kicked off. And so yes, on a pull request, you kick off a build that will test, the APIs, and then if that passes, then or runs the unit test and that passes, then run the API test and that passes, then run the UI tests, or if it makes sense to run them all at the same time. But yes, typically that's going to be part of your build system, whatever that looks like for you. And specifically what I am showing, I think, is not specifically API tests directly, but it's combining. There are things that you could do with the API that what the example I showed would not test. But what I am showing here is a way to leverage the API with the UI to make sure that you're getting the right information. But it wouldn't be enough to fully exercise everything that your API needs to do. So you would want a separate test suite of just quick interactions with the service layer for what the API, when I receive this, am I doing this type tests.
Okay, good, thank you. Hans, this one came in during your presentation. And our listener asks, is it affordable to combine interaction and business tests? Because if you test these two types separately, it can take much more time and effort.
Yeah, that is a good question. What I show is a kind of a pre-structure. That means you identify interaction test as a possible category of test that you want to do. You can always decide not to do that, or to do it only at a limited scale, or even if you want to combine it back into the business test. I generally don't recommend the last part, but if you don't have a lot of time, I would guess run the business test first, the end-to-end test, so that you know that your business object life cycles at least work. You can enter a new customer, that customer can rent a car, can get an invoice, can pay by a credit card, etc.
And just to add on to that, it's kind of like what I was saying as far as like the functionality versus the navigation. It's the exact same thing. Like you could do all of the navigation and test each of those things, or you could just have the browser directly go to the page you need to be on and then verify that specific functionality. And it's just a matter of what's most important and where do you start, and how thoroughly are you looking to get. The more tests you have, the more likely you're going to have failures and the more maintenance headaches you're going to have. And so there's a balance between, do I need to add this test, and am I getting enough coverage? And so that's just a constant balance you have to strike.
Yeah, this is also the reason I like to talk about design. And when I talk about test design, means you make choices. If you want an office building, you can specify what that office building needs to be, how many floors, how many square footage. You go to 2 different architects to design it for you. You will get 2 different buildings that might look very different from each other, even though they have the same functionality. So it is part science, it's part art. And in that process, you design the test. What I try to make clear, and Titus also, is try to make it explicit, make design decisions.
That's interesting, because we had a question early on, and I think this may play off a bit of what you just described, but we have a question that's, how would you best describe test design to somebody with no testing background at all?
That's a good question. The challenge there is to show the problem. People with no test background at all, which is getting more and more common with the coming of Agile. You see multidisciplinary teams like QA and developers and product owners. And then at the management level, you see sometimes the QA manager being phased out, which I think is a very bad thing, because QA is still a very different skill from, for example, development. But you need to make the problem understood, so that the manager understands why test design is important for automation. For example, you could play back this particular webinar for him or her, just to give that idea that it actually matters. And then for the rest, you need to be very professional in making that test design. And the reason I use a pre-structure, like the closet with the shelves, is that in that process, that doesn't take much time, developers can participate and automation engineers. So the tester, the non-technical tester, is not alone. There will be people around him or her helping with that structure. Once that structure is in place, testers can handle it perfectly by themselves. You don't need developers for that anymore, even if they're not technical. I hope that answered it.
No, that was great. Thank you. It just does seem also to support the fact that you need a design first because you're ultimately going to save time and money rather than just going at it ad hoc. Titus, we have a question here. Do you have any recommended resources, blogs, tutorials, books on automated API test design?
For API specifically?
Yeah, it was clarified as automated API test design.
Yeah, I'm not sure. I guess I kind of look at some of that stuff as being much more unit test. I see a much smaller difference between writing unit tests and API tests than I do API tests and UI tests, even though API tests often are black box as well. It's just a matter of understanding what like for unit test, you're just understanding for this specific endpoint or method on this class, what kind of inputs can come in and what outputs should come out for those inputs, what exceptions and things like that. And so to a certain extent, that means understanding what the API does really well and making sure that the inputs and the outputs match, and that requires a little bit more knowledge of the system, I think, than doing a lot of the UI tests, where for the most part you can create UI automation without really needing to understand how the system works. You just need to know what's expected of it. And I think that's a little different from the approach I would take to automating an API. And as far as resources to send someone to, I do not have anything off the top of my head.
I'll tell you what, I'll get together with you and Hans, and maybe we can come up with a blog post. Here's one that's kind of very relevant, particularly to the start of the presentation, but should manual tests always be designed keeping automation in mind?
Maybe I'll pick that up. I would, if I had a say in it. I would try to keep that automation in mind. The big exception being exploratory testing, which I touched upon in the presentation. That's really meant to be an interactive process with the system under test. Exploratory testing is very good in finding bugs, actually better than most automated tests can do. So, but other than that, internally we have some rules which we call the 5% rules. You should be no more than 5% of your tests should be manual, and you should achieve that with no more than 5% of your testing efforts. So 95% should be automated, and 95% of people should be working on test design and not on the automation. Now that is obviously fairly uphill, but that might help you as a norm. And basically, the rule that I have is every test that you write down, even if it's just on the back of an envelope, you should try to automate. Unless it's a really one-time only test.
Well, and just to jump in there, I think this is like the power of the visualization of that testing pyramid is really trying to make sure that stuff is tested at the right level. And so absolutely, I think it makes sense if you're doing manual testing to keep in mind that you're not duplicating things that have already been done. So if you have UI tests that are essentially copying, like if there's no way for a UI test to fail without a unit test also failing, then there's no reason to have that UI test, as an example. And like figuring out if that's the case is obviously the difficulty, but that's the idea is, hey, should I be testing the sort method in the UI, or should I just be making sure that the UI is displaying certain values from the API, and then all of the sorting and stuff like that happens at the API level instead of at the UI level. So things like that. So again, if you know that you're manually testing things that there are already automation tests for, yeah, it's definitely something to keep in mind that you want to do more of the faster things to get faster feedback than the slower things that take longer and don't scale as well.
That's great. I have one, I think that is for you, Titus, and that is for a CI practice where testing will fit better before or after a pull request.
Oh yeah, so this gets into all kinds of possible issues as far as, feature branched CI/CD or trunk based, but essentially it's a matter of the goal is to have master or whatever your primary branch be something that can be delivered into production at any time. And so you just have to make sure that you have a process that works with everything else that's going on. Oftentimes people are doing, it's more common right now that there's feature branches rather than like a true trunk development process. And typically with feature branches, you do a lot of work in one branch and then you go to merge it into master. And before it gets into master, you want to run all of the checks to make sure that it hasn't broken something unexpected, and then it gets merged into master, and now master's in a known good state, and then another branch would get merged. But obviously there's a lot more chance for there to be merge conflicts and things like that when you have lots of changes being made in multiple branches at the same time, which is why some people are moving more towards the mono repos and the trunk-based, always committing everything to master. But there's a level of maturity that makes that much more difficult to get to.
Okay, well, thank you. So we are just now at the top of the hour. We've gotten a lot of good feedback in terms of how helpful this presentation has been. So I really want to thank both of you, Hans and Titus, for taking the time, as well as everyone else for spending an hour with us. We will be sending out an email with a link to the recording and slides in a day or two after this. And so with that, we will go ahead and sign off and wish everyone a very good Wednesday. Thanks again.